In October 2025, something extraordinary happened in the Chernobyl exclusion zone that captured the attention of scientists, journalists, and conspiracy theorists worldwide. Photographs began circulating on social media showing stray dogs with bright blue fur wandering through the abandoned streets near the infamous nuclear power plant. The images were startling and immediately sparked intense speculation. Were these animals victims of a new radiation leak? Had genetic mutations finally manifested in visible, terrifying ways nearly 4 decades after the disaster? The truth, as it turns out, would prove to be both stranger and more mundane than anyone initially imagined. The Chernobyl exclusion zone, established in the aftermath of the April 26, 1986 nuclear disaster, encompasses approximately 1,000 square miles of land surrounding the destroyed reactor. This area, deemed too contaminated for human habitation, has become an unlikely sanctuary for wildlife. Among the most remarkable inhabitants are the stray dogs, descendants of pets abandoned when nearly 120,000 people were forcibly evacuated from the region in the days and weeks following the explosion. These dogs have survived against all odds in one of the most radioactive environments on Earth, adapting to a landscape frozen in time, where nature has slowly reclaimed the ghost towns of Pripyat and surrounding settlements. When the blue dog photographs emerged, the timing couldn't have been more alarming. The world was already on edge about ongoing concerns at Chernobyl, including the deteriorating condition of the new safe confinement structure, the massive steel and concrete sarcophagus built to contain the remains of Reactor 4. Additionally, recent scientific studies had revealed that the dogs at Chernobyl showed genetic differences from typical dog populations, suggesting that decades of radiation exposure had indeed left its mark on their DNA. The appearance of blue-furred canines seemed to confirm humanity's worst fears about the long-term consequences of nuclear contamination. Social media exploded with theories ranging from scientific speculation to outright conspiracy, with some claiming government cover-ups and others predicting an impending environmental catastrophe. Dr. Lucas Brenner, a veterinarian who has been working with the Clean Futures Fund to provide medical care to the Chernobyl dogs, was among the first experts to investigate the phenomenon when reports reached his team. What he discovered would eventually solve the mystery, but not before the story had captured global attention and reignited debates about nuclear safety, environmental monitoring, and the lasting legacy of Chernobyl. The blue dogs have become international celebrities overnight, symbols of both the resilience of nature and the permanent scars left by humanity's most catastrophic nuclear accident. The initial response from the scientific community was cautious but concerned. Researchers who had been studying the Chernobyl ecosystem for years knew that the dogs faced numerous health challenges due to their environment. Previous studies had documented higher rates of cancer, shorter lifespans, and various physiological abnormalities in the population. The possibility that radiation might be causing visible pigmentation changes was taken seriously enough to warrant immediate investigation. Environmental activists call for renewed international attention to the ongoing challenges at Chernobyl, while nuclear safety experts emphasize the need for continuous monitoring of the exclusion zone. The blue dogs, whatever their origin, had succeeded in reminding the world that Chernobyl's story was far from over. To understand the significance of the blue dogs' mystery, we must first revisit the catastrophe that created their unnatural habitat. On April 26, 1986, at 1:23 a.m. local time, Reactor number 4 at the Chernobyl nuclear power plant exploded during a safety test that went catastrophically wrong. The explosion was caused by a sudden power surge that the operators could not control, resulting in a series of steam explosions and a fire that raged for 10 days. The blast blew the 1,000-ton steel and concrete lid off the reactor, exposing the core and releasing massive amounts of radioactive material into the atmosphere. This was not merely an industrial accident. It was a world-changing event that would redefine nuclear safety protocols and leave a permanent scar on the landscape of what is now Ukraine. The immediate aftermath was chaotic and deadly. Firefighters and plant workers, many of whom had no idea the true danger they faced, rushed to combat the flames and prevent further explosions. These first responders received lethal doses of radiation within minutes of exposure. 2 plant workers died in the initial explosion, while 28 more would succumb to acute radiation syndrome in the weeks that followed. These men, later known as the Chernobyl liquidators, made the ultimate sacrifice, but they were only the beginning of a much larger human toll. Over the following months and years, hundreds of thousands of additional liquidators will be called upon to contain the disaster, many of them Soviet soldiers, miners, and conscripted workers who had little choice in the matter. The radioactive plume, released by the explosion, carried contamination across vast swathes of Europe. While the heaviest fallout settled on areas of Ukraine, Belarus, and Russia, radioactive particles were detected as far away as Sweden, where monitoring stations first alerted the world to disaster when the Soviet government was still maintaining silence. The evacuation of Pripyat, the city built to house Chernobyl workers and their families, began 36 hours after the explosion. Residents were told they would be gone for only 3 days and should leave most of their belongings behind. They never returned. The haunting image of the abandoned city, with its famous Ferris wheel and empty apartment blocks, has become one of the most powerful symbols of the nuclear age. Among the most heart-wrenching aspects of the evacuation was the fate of pets. Authorities determined that animals could carry radioactive contamination on their fur and pose a risk to evacuated families. Soviet soldiers were ordered to shoot dogs and cats left behind in the exclusion zone. Thousands of pets were killed in the weeks following the disaster, but not all. Some animals survived by fleeing into surrounding forests or hiding in abandoned buildings. These survivors will become the founders of the current population of Chernobyl dogs, animals that have now lived through nearly 40 generations in this contaminated wilderness. The descendants of these abandoned pets have developed into semi-feral populations, though many remain remarkably friendly toward the humans who occasionally work in the zone. The long-term impact of Chernobyl on human health remains a subject of scientific debate and political controversy. The World Health Organization estimates that up to 4,000 people may eventually die from radiation-related illnesses caused by the disaster, though other organizations put the figure much higher, potentially reaching tens of thousands. Thyroid cancer rates spiked dramatically among those exposed to radioactive iodine, particularly children who consumed contaminated milk in the days after the explosion. The psychological toll has been equally devastating, with entire communities displaced, traditional ways of life destroyed, and a pervasive anxiety about health effects that persist to this day. The economic cost has been astronomical, with some estimates placing it at hundreds of billions of dollars when cleanup, relocation, and lost productivity are factored in. Chernobyl stands as a stark reminder of both the potential of nuclear technology and the catastrophic consequences when that technology fails. The Chernobyl exclusion zone is one of the most unusual places on Earth, a landscape where nature and radiation exist in an uneasy coexistence. Established shortly after the disaster, the zone was initially a 30-kilometer radius around the reactor, though the boundaries have been adjusted over time to reflect actual contamination patterns. Today, the zone remains largely off-limits to permanent human habitation, though scientists, maintenance workers, and increasingly tourists are granted limited access. The area has been described as an involuntary park, where the absence of human activity has allowed wildlife to flourish despite elevated radiation levels that persist in soil, water, and vegetation. The radiation distribution within the exclusion zone is far from uniform. Some areas remain extraordinarily dangerous, with hotspots where exposure can deliver lethal doses within hours. The most contaminated site is known as the Red Forest, a section of pine woodland that stood directly in the path of the radioactive plume. The trees absorbed so much radiation that they turned reddish-brown and died shortly after the accident. The dead trees were bulldozed and buried, but the area remains one of the most radioactive places on the planet. In contrast, other parts of the zone have radiation levels that, while elevated, are comparable to natural background radiation in some high-altitude locations. This patchwork of contamination creates a complex environment where animals may move between relatively safe areas and radiation hotspots, accumulating doses that vary dramatically based on their ranging patterns. The dogs of Chernobyl have adapted to this challenging environment in remarkable ways. Estimates suggest there are approximately 700 stray dogs currently living in the exclusion zone, though exact numbers fluctuate. These animals have developed behavioral patterns that maximize their chances of survival in a landscape devoid of traditional pet resources. Many congregate near the Chernobyl nuclear power plant itself, which remains partially operational with a workforce that maintains the new safe confinement structure and monitors the entombed reactor. These workers have become an informal support system for the dogs, providing food scraps and occasional medical care. Other dogs have become more feral, living in packs in the forests and abandoned towns, hunting small mammals and scavenging from the remnants of human civilization. Studying the Chernobyl dogs has become a priority for scientists interested in how radiation affects mammalian populations over multiple generations. Unlike the short-term acute effects seen in the immediate aftermath of the disaster, these dogs represent a unique opportunity to observe chronic, low to moderate radiation exposure across dozens of generations. Research teams from the United States, Europe, and Ukraine have conducted extensive studies, including comprehensive genomic sequencing, to identify genetic changes that might be linked to radiation exposure. The findings have been both fascinating and concerning, suggesting that the dogs have indeed accumulated genetic variations that distinguish them from dogs in non-contaminated areas. The broader ecosystem of the exclusion zone has become a subject of intense scientific interest. In the absence of human activity, large mammal populations have exploded. Wolves, wild boar, deer, and even endangered species like the Przewalski's horse now thrive in numbers not seen in this region for centuries. Birds of prey circle overhead, and beavers have rebuilt extensive wetland systems. From a distance, the exclusion zone looks like a conservation success story, a testament to nature's resilience. However, closer examination reveals the darker reality. Many animals show signs of radiation damage at the cellular level, including increased mutation rates, chromosomal abnormalities, and reduced lifespans. Plants in highly contaminated areas exhibit unusual growth patterns and genetic mutations. The Chernobyl ecosystem is thriving, but it is also fundamentally altered, a living laboratory for understanding how life adapts or fails to adapt to chronic radiation exposure. When the first images of blue dogs appeared on social media platforms in late October 2025, the response was immediate and overwhelming. Twitter, Instagram, and Facebook users shared the photographs thousands of times within hours, with hashtags like #ChernobylBlueDogs and #RadioactiveMutants trending globally. The dogs in question weren't just slightly tinted. They were spectacularly, vibrantly blue, with fur that looked as if it had been dyed with artificial coloring. The surreal nature of the images, set against the post-apocalyptic backdrop of abandoned Soviet-era buildings, created a visual narrative that was impossible to ignore. Here, seemingly, was proof that something new and disturbing was happening in the world's most famous nuclear disaster zone. Mainstream media outlets quickly picked up the story. News websites from New York to Tokyo ran articles speculating about the cause of the blue coloration. Television news programs interviewed nuclear experts, veterinarians, and environmental scientists, all attempting to explain what could turn a dog's fur bright blue. The speculation ranged widely. Some experts suggested that new radiation leaks might be causing unprecedented mutations. Others wondered if industrial pollutants had been illegally dumped in the exclusion zone. Conspiracy theorists proposed more exotic explanations, including secret government experiments and even alien involvement. The mystery of the blue dogs had become a global phenomenon, a modern campfire story that combined our fascination with Chernobyl, our fear of radiation, and our love of animals into one compelling narrative. The timing of the discovery added to the sense of urgency and concern. In 2025, the world was grappling with renewed anxieties about nuclear safety following a series of high-profile incidents at aging nuclear facilities worldwide. The war in Ukraine had brought international attention back to Chernobyl when Russian forces briefly occupied the site in 2022, raising fears about the safety of the containment structures. Against this backdrop, the appearance of blue dogs seemed to suggest that Chernobyl's dangers were evolving in unpredictable ways. Environmental advocacy groups seized upon the story to highlight ongoing concerns about nuclear waste management and the long-term monitoring of contaminated sites. Scientists working in the exclusion zone found themselves inundated with media requests. Dr. Lucas Brenner and his colleagues at the Clean Futures Fund, a nonprofit organization dedicated to providing veterinary care to Chernobyl stray animals, were among the first to be contacted. The organization had been operating in the zone since 2017, conducting regular veterinary missions that included spaying and neutering programs, vaccinations, and treatment for sick and injured dogs. Their team had extensive experience with the local canine population and had never observed anything like the blue coloration before. This was new, which meant it required immediate investigation to determine whether it represented a threat to the dogs, to the workers in the zone, or to the broader environment. As the story spread, it took on a life of its own beyond the facts. Photoshop images claiming to show other blue animals in Chernobyl began circulating, along with fabricated quotes from officials and scientists. Misinformation spread as rapidly as a legitimate story, making it increasingly difficult for people to separate fact from fiction. Some social media users claimed the dogs were glowing in the dark, while others insisted they had personally witnessed packs of blue wolves roaming the forests. The viral nature of the phenomenon demonstrated both the power of social media to spread awareness and its tendency to amplify sensationalism over substance. The real scientific investigation was only just beginning, but in the public imagination, the blue dogs at Chernobyl had already become legendary. When Dr. Lucas Brenner and his team received reports of blue dogs in the Chernobyl exclusion zone, they immediately mobilized to investigate. The Clean Futures Fund operates under strict protocols when working in the zone, coordinating with Ukrainian authorities and radiation safety experts to ensure that their veterinary missions don't expose team members to dangerous levels of contamination. For this particular investigation, the team prepared to conduct comprehensive examinations of the affected dogs, collecting fur samples, blood samples, and detailed photographic documentation. The goal was to determine not only what had caused the blue coloration, but also whether it posed any health risks to the animals or indicated broader environmental problems. The first challenge was locating the blue dogs. The exclusion zone is vast, and the stray dog population is distributed across hundreds of square miles of forests, towns, and industrial sites. Reports had come from workers at several locations within the zone, suggesting that multiple dogs had been affected. The team began their search at the Chernobyl nuclear power plant complex itself, where the highest concentration of workers, and therefore the most reliable witnesses, were located. It didn't take long to find what they were looking for. Several dogs that regularly congregated near the plant's cafeteria, hoping for handouts from sympathetic workers, were indeed sporting bright blue fur on their backs, sides, and legs. The initial physical examination of the dogs revealed important clues. The blue coloration was not uniform across the animals' bodies. Rather, it appeared primarily on areas that would come into contact with the ground when the dogs rolled or laid down, the back, flanks, and sometimes the legs and belly. The fur itself didn't appear to be damaged or affected in structure. The colors seemed to be coating the hair rather than arising from within it. This observation was crucial because it suggested an external substance rather than an internal biological change. If radiation or genetics were causing blue pigmentation, it would likely affect fur growth in follicles, resulting in blue fur emerging evenly across the dog's body. The pattern observed suggested the dogs had been exposed to something blue that had stained their fur. Sample collection proceeded carefully. The team shaved small sections of blue fur from several dogs, bagged the samples for laboratory analysis, and also collected control samples of normal-colored fur from the same animals. Blood samples were drawn to check for any unusual chemical compounds or health anomalies. The dogs, accustomed to human interaction from years of living alongside zone workers, were generally cooperative, though the veterinary team took precautions to ensure the animals weren't stressed by the examination. Throughout this process, the researchers were also monitoring themselves for radiation exposure using dosimeters, as working in close proximity to the dogs and collecting samples that might be contaminated required strict safety protocols. While field investigation continued, laboratory analysis of the first samples began immediately. Initial tests focused on identifying the chemical composition of the blue substance. Was it organic or inorganic? Did it contain radioactive isotopes? Were there heavy metals or industrial pollutants present? The samples were subjected to spectroscopy, chromatography, and microscopic examination. Meanwhile, the team also began a systematic search of the areas where blue dogs had been spotted, looking for the source of the blue substance. They investigated buildings, open areas, and sites where the dogs were known to spend time. The scientific method was in full operation, observe, hypothesize, test, and refine understanding based on evidence. What they would discover would solve the mystery in a way that was both anticlimactic and weirdly funny. The answer to Blue Dog's mystery turned out to be both simpler and more disgusting than anyone had anticipated. Dr. Lucas Brenner's investigation led him to a portable toilet, specifically a blue chemical porta potty that had been toppled over near one of the work sites in the exclusion zone. When the unit tipped, it spilled its contents, including the distinctive blue chemical solution used in these facilities to control odor and break down waste. This bright blue liquid, containing compounds like formaldehyde and dyes, had pooled in an area where the dogs were known to frequent. And dogs, being dogs, had done what dogs do. They rolled in it. The discovery was made when team members were conducting a systematic search of areas where blue dogs had been observed. They noticed the overturned porta potty and the telltale blue staining on the ground surrounding it. The pieces fell into place immediately. Dogs have an instinct to roll in strong-smelling substances, a behavior that may date back to their wolf ancestors who would disguise their own scent with other smells to aid in hunting or avoid detection. In the case of the Chernobyl dogs, the pungent chemical mixture from the porta potty was evidently irresistible. Multiple dogs had rolled enthusiastically in the spilled chemicals, coating their fur with a vibrant blue dye and the decidedly unpleasant accompanying substances. Laboratory analysis of the first samples confirmed this hypothesis. The blue substance coating the dogs fur matched the chemical composition of the compounds used in portable toilet facilities. Specifically, the samples contained blue dye number 1, brilliant blue FCF, a common coloring agent used in porta potty chemicals, as well as trace amounts of formaldehyde and quaternary ammonium compounds, both typical components of chemical toilet solutions. There were no unusual levels of radioactive isotopes, no mysterious industrial pollutants, and no evidence of genetic mutations affecting pigmentation. The blue dogs at Chernobyl had simply gotten into something they shouldn't have, in the most literal and disgusting sense possible. The reaction to this explanation was mixed. Many people who had been following the story with concern felt relief that the blue coloration didn't indicate new radiation problems or environmental contamination. Scientists and environmental advocates appreciated that the mystery had been solved through proper investigation rather than speculation. However, there was also a degree of disappointment among those who had been captivated by the more exotic explanations. The blue dogs had been, for a brief moment, a symbol of Chernobyl's ongoing mysteries and dangers. Learning that they were simply dirty dogs or found something foul to roll in was decidedly less dramatic. Social media responses ranged from amused to mildly embarrassed, with many users who had shared alarming theories now sheepishly acknowledging the mundane reality. For the dogs themselves, the blue coloration was largely harmless, though the chemical exposure was certainly not ideal. The compounds in porta potty chemicals are designed to be relatively non-toxic to humans and animals, though they're not meant to be applied directly to skin or fur. The veterinary team monitored the affected dogs for any signs of skin irritation, chemical burns, or other adverse reactions. Most of the dogs showed no ill effects beyond the blue staining, which would gradually fade as they groomed themselves and as the chemicals were exposed to sunlight and weather. In some cases, the team provided baths to help remove the blue substance more quickly, though convincing a semi-feral dog to accept the bath in Chernobyl's chilly October, weather was its own challenge. The blue dog's mystery had been solved, but it had revealed something important about how quickly viral stories can spread and how easily people can assume the worst when it comes to places like Chernobyl. While the blue dog's mystery was solved, it raised an interesting question that dog owners worldwide have pondered for generations. Why do dogs roll in disgusting substances? This behavior is one of the most universally observed traits among domestic dogs and their wild relatives, and it drives pet owners to distraction. From feces to dead fish to chemical toilet waste, dogs seem to have an irresistible compulsion to coat themselves in the most offensive-smelling substances they can find. The behavior is so common and so consistent across breeds and environments that it clearly serves some evolutionary purpose, even if that purpose has become somewhat obsolete in the modern domestic context. The most widely accepted explanation relates to dogs' ancestry as pack hunters related to wolves. In the wild, predators benefit from masking their scent when hunting. by rolling in the scent of other animals, including dead animals, dung, or other strong odors. Wolves may disguise their own predator's smell, making it easier to approach prey without alerting them. This scent camouflage could provide a crucial advantage when hunting cautious prey species. Some researchers also suggest that wolves may roll in unusual scents and then return to the pack, essentially bringing home information about food sources or other important discoveries in their territory. In this context, the behavior functions as a form of communication, with scents serving as the message medium. Another theory suggests that rolling in strong smells is related to status and information sharing within pack social structures. When a wolf finds something interesting, like a dead animal or an unusual substance, rolling in it and carrying the scent back to the pack allows other members to gather information about what's available in the environment. Younger or subordinate pack members might be particularly motivated to engage in this behavior as a way of contributing useful information to the group. The dog who returns wearing the scent of something novel becomes, in effect, a walking bulletin board advertising what's available in the territory. From a purely sensory perspective, dogs experience the world primarily through smell in a way that humans struggle to comprehend. While humans have approximately 5 million olfactory receptors in their noses, dogs have up to 300 million, depending on breed. The portion of a dog's brain devoted to analyzing smells is proportionally 40 times larger than the comparable region in human brains. For dogs, scents provide rich, detailed information that we can barely imagine. What smells absolutely revolting to human noses might be genuinely interesting, even pleasant, to a dog's sensory perception. The act of rolling in a strong scent might simply be deeply satisfying to an animal whose primary sense is smell, comparable to how humans might appreciate a beautiful sunset or enjoy favorite music. In the case of the Chernobyl blue dogs, all of these instinctive behaviors likely played a role. The overturned porta potty presented an intensely strong smell that would have been immediately noticeable to any dog in the vicinity. The novelty of the scent, combined with its chemical intensity, probably proved irresistible to the dog's instincts. They rolled in it for the same reason dogs everywhere roll in questionable substances, because millennia of evolution have programmed them to find such behavior rewarding, even though their modern circumstances as semi-feral animals living off human handouts in an abandoned nuclear zone have made scent camouflage largely unnecessary. The behavior persists because evolution works on very long timescales, and domestic dogs are, in genetic terms, still very much like their wild ancestors despite thousands of years of selective breeding. The blue dogs of Chernobyl were simply following instincts that have served canines well for hundreds of thousands of years, even if those instincts led them to roll in portable toilet chemicals. While the blue dogs turn out to be a false alarm in terms of radiation-induced mutations, legitimate scientific research has revealed that the dogs of Chernobyl have indeed undergone genetic changes as a result of their unique environment. Multiple studies conducted over the past several years have examined the DNA of Chernobyl dogs and compared it to dogs living in non-contaminated areas. The results have been both fascinating and concerning, providing insights into how chronic radiation exposure affects mammalian genetics over multiple generations and offering potential lessons about radiation biology that could have implications for both medicine and environmental science. A comprehensive study published in early 2023 by researchers from Princeton University, the University of South Carolina, and several Ukrainian institutions examined the genomes of 302 dogs living in the Chernobyl exclusion zone. The research team collected DNA samples during veterinary care missions, documenting each dog's location within the zone to correlate genetic changes with radiation exposure levels. The findings revealed that Chernobyl dogs have indeed developed genetic differences from dog populations living in uncontaminated areas, with distinct genetic signatures in dogs living near the power plant compared to those living in the town of Chernobyl, about 15 kilometers away, where radiation levels are lower. The genetic variations identified in Chernobyl dogs appear in several key areas. Some changes involve DNA repair genes, the cellular machinery responsible for fixing damage to genetic material. Dogs living in the most contaminated areas show variations in these genes that may enhance their ability to repair radiation-induced DNA damage. This represents a form of rapid evolution, where natural selection has favored individuals better equipped to to survive in a radioactive environment. Other genetic differences involve immune system function, metabolic processes, and stress response pathways. These changes suggest that the dog's bodies have been adapting at the molecular level to cope with challenges specific to the exclusion zone environment. Perhaps most remarkably, research published in December 2024 suggested that Chernobyl dogs might have developed something approaching a superpower: enhanced resistance to cancer and radiation damage. Scientists studying the dogs found that some individuals showed unusual resistance to radiation-induced cellular damage. When their cells were exposed to radiation in laboratory tests, they exhibited better survival rates and more effective DNA repair than cells from dogs living in normal environments. The researchers identified specific genetic markers associated with this enhanced resistance, suggesting that natural selection has been operating at remarkable speed in the Chernobyl dog population. Dogs born with genetic variations that provide even slight advantages in surviving and reproducing in a radioactive environment have passed those advantages to their offspring, and the process has repeated across nearly 40 generations. However, it's crucial to understand that these genetic adaptations don't mean the dogs are thriving or that radiation is harmless. The dogs of Chernobyl face numerous health challenges. They have shorter average lifespans than dogs in normal environments, higher rates of cancer and other diseases, and various physiological problems related to chronic radiation exposure. The genetic changes observed represent survival adaptations that have allowed the population to persist in extraordinarily difficult conditions, not evidence that radiation exposure is benign. The dogs are surviving despite the radiation, not because of it. The genetic research is valuable precisely because it illuminates the biological mechanisms of radiation damage and repair, potentially informing cancer treatment strategies, radiation protection protocols for human workers in hazardous environments, and our understanding of how ecosystems respond to contamination. The Chernobyl dogs are living subjects in a tragic natural experiment, and while their blue fur turned out to be nothing more than an accident with a porta potty, their actual genetic changes tell a profound story about adaptation, survival, and the lasting consequences of nuclear disasters. The Blue Dogs episode perfectly illustrates the gap between viral media narratives and scientific reality, particularly when it comes to emotionally charged topics like radiation and nuclear disasters. From the moment the first images appeared on social media, the story took on a life of its own, with each retelling adding layers of speculation, exaggeration, and misinformation. This phenomenon is not unique to the Chernobyl dog story. It represents a broader pattern in how modern media ecosystems handle scientific stories, especially those involving potential dangers or mysterious phenomena. The initial spread of the Blue Dog story followed a predictable pattern. Eye-catching images were shared with alarming headlines that prioritize engagement over accuracy. Radioactive mutant dogs discovered in Chernobyl was more likely to generate clicks and shares than dogs in Chernobyl have something blue on their fur, cause unknown. News outlets, competing for audience attention in a crowded digital landscape, rushed to cover the story without waiting for complete information. Many articles hedge with phrases like, "may be caused by radiation" or "possibly linked to new contamination," but the headlines and social media posts often presented speculation as fact. The result was a global audience that became convinced something extraordinary and frightening was happening in Chernobyl before any scientific investigation had even begun. The role of visual media was particularly significant in this case. The photographs of blue dogs were inherently striking and shareable. They required no scientific background to understand. Anyone could see that these dogs looked unusual, and the juxtaposition of bright blue animals against the gray, post-apocalyptic backdrop of abandoned Soviet buildings created a powerful visual narrative. Images drive social media engagement far more effectively than text, and unusual or alarming images perform especially well. The Blue Dogs photos were perfectly optimized for viral spread, which ensured the story reached millions of people within hours. However, very few of those millions would later see the follow-up stories explaining the prosaic reality of overturned porta potties. This asymmetry between the reach of alarming initial reports and the reach of subsequent corrections is one of the most challenging aspects of science communication in the digital age. Studies of misinformation spread have consistently shown that false or sensational stories spread faster and wider than corrections. By the time Dr. Brenner and his team had identified the actual cause of the blue coloration, the The story had already reached its peak virality. The explanation, while relieving, was simply less interesting to most people than the initial mystery. News outlets that had covered the story prominently often relegated the explanation to smaller follow-up articles or brief updates. Many people who saw the original blue dog photos and alarming headlines never encountered the factual explanation, potentially leaving them with lasting misimpressions about new radiation dangers at Chernobyl. The incident also highlights the importance of scientific literacy and critical thinking when consuming news. Several clues in the original story should have prompted skepticism among careful observers. Radiation-induced mutations don't typically produce bright, uniform colors in mammalian fur. Such mutations generally cause structural problems, health issues, or subtle changes in cellular function rather than dramatic pigmentation changes. The blue coloration appeared suddenly in multiple dogs simultaneously, rather than emerging gradually over time as would be expected with genetic changes. The color was exceptionally bright and uniform, more consistent with artificial dyes than biological processes. Experts consulted by responsible journalists often express caution about jumping to radiation-related conclusions, but these measured responses were frequently overshadowed by more dramatic speculation. The Blue Dog story ultimately serves as a case study in how scientific stories spread in modern media ecosystems, revealing both the opportunities for raising public awareness about important issues and the risks of misinformation, oversimplification, and sensationalism that can distort public understanding of science. One of the most touching aspects of the Chernobyl dog story is their relationship with the humans who work in the exclusion zone. Approximately 2,500 people work at Chernobyl at any given time, including engineers, technicians, security personnel, guides, and various support staff. These workers maintain the new safe confinement structure, monitor radiation levels, conduct research, and facilitate the growing number of tourists who visit the site. For many of these workers, the stray dogs have become unofficial companions, bringing moments of normalcy and emotional connection to an otherwise surreal work environment. The dogs congregate particularly heavily around the Chernobyl nuclear power plant complex itself, where the workers are concentrated. The cafeteria and break areas are favorite spots, as sympathetic workers share food with the animals. Over time, individual relationships have developed between specific workers and specific dogs. Workers have given names to many of the animals, recognized them as individuals, and tracked their well-being over months and years. For people working in one of the most infamous locations on Earth, surrounded by reminders of catastrophic failure and human suffering, the presence of friendly dogs provides a psychological lifeline, a reminder that life persists even in the most unlikely places. This relationship between workers and dogs was not always so positive. In the immediate aftermath of the 1986 disaster, as discussed earlier, authorities ordered the killing of pets left behind in the evacuation. Soviet soldiers were tasked with shooting dogs and cats to prevent them from spreading radioactive contamination. This grim duty was traumatic for many of the soldiers involved, and is one of the darker chapters in Chernobyl's history. The fact that dogs survived this culling and established breeding populations is itself remarkable. Today's Chernobyl dogs are the descendants of those survivors, and the workers who now care for them are, in a sense, rectifying the harsh treatment the animals' ancestors received. Organizations like the Clean Futures Fund have formalized a relationship between workers and dogs through structured veterinary care programs. Since beginning operations in 2017, the Clean Futures Fund has spayed or neutered over 1,000 dogs in the exclusion zone, vaccinated hundreds more against rabies and other diseases, and provided medical treatment for injuries and illnesses. These interventions serve multiple purposes. They improve the welfare of individual animals, reduce the overall population to sustainable levels, and minimize public health risks associated with unvaccinated stray dogs in an area where workers are present. The organization relies heavily on the cooperation of zone workers, who help identify dogs in need of care, assist with gentle capture methods, and provide post-procedure monitoring. The presence of the dogs also serves an unexpected psychological function for research scientists and emergency responders who train at Chernobyl. The site is used as a training ground for nuclear disaster response scenarios, and the abandoned buildings, radiation monitoring equipment, and post-apocalyptic atmosphere can be deeply unsettling for trainees. The friendly dogs that approach workers looking for attention and treats provide a jarring, but welcome contrast to the otherwise bleak environment. They remind people that Chernobyl is not simply a dead zone or a monument of disaster. It's a place where life continues, adapts, and even thrives in unexpected ways. When the blue dogs appeared in October 2025, the workers who knew these animals individually were among the first to express concern and seek help from veterinary organizations. Their care for the dogs exemplifies one of the better aspects of human nature, our capacity for compassion toward other species, even in challenging circumstances. The story of Chernobyl's dogs is thus not only a story about radiation biology and adaptation, but also about the bonds between humans and animals that persist even in the world's most contaminated places. While the dogs at Chernobyl have captured public attention, they're far from the only animals thriving in the exclusion zone. In the nearly 4 decades since humans abandoned the area, wildlife populations have exploded in ways that have surprised and fascinated ecologists. The Chernobyl exclusion zone has become what scientists call an involuntary nature reserve, demonstrating that for many species, the absence of humans is more beneficial than the presence of radiation is harmful. This paradoxical situation has provided unique opportunities to study how ecosystems respond to both contamination and human abandonment, yielding insights that challenge simple narratives about the environmental impacts of nuclear disasters. Large mammal populations in the exclusion zone are particularly impressive. Wolves now number in the hundreds, with population densities significantly higher than in surrounding areas where humans are present. These wolves have become apex predators in an ecosystem with abundant prey and no human hunters to fear. Studies tracking Chernobyl wolves with GPS collars have shown that they occasionally leave the exclusion zone and travel into surrounding areas, potentially spreading genetic mutations to broader wolf populations. Wild boar populations have similarly exploded, creating challenges for agricultural areas adjacent to the exclusion zone as the animals raid crops and carry radioactive contamination with them when they cross boundaries. Other large mammals documented in the zone include moose, red deer, roe deer, beavers, brown bears, and European lynx. Most remarkable is the presence of the critically endangered Przewalski's horse, a species that went extinct in the wild in the 1960s. In the 1990s, conservationists introduced a small population to the Chernobyl zone, reasoning that the abandoned landscape provided ideal habitat despite the radiation. The horses have established a breeding population, offering hope for this endangered species, while also serving as subjects for radiation biology research. Camera trap studies conducted by University of Georgia researchers have documented at least 14 species of large mammals in the zone, with population abundances comparable to or exceeding those in uncontaminated nature reserves in the region. The bird populations of Chernobyl present a more complex picture. While many species are present in abundance, research has documented concerning effects of radiation on avian populations. Studies have found that birds in highly contaminated areas show elevated rates of abnormalities, including albinism, malformed beaks, and unusual tumors. Some species show population declines in the most contaminated regions, while others seem relatively unaffected. Barn swallows nesting in radioactive buildings show higher rates of genetic mutations, including changes in plumage coloration and structure. These findings suggest that birds, with their higher metabolic rates and different life history strategies compared to mammals, may be more vulnerable to radiation effects. Smaller creatures and plants tell still different stories. Insects in contaminated areas show various abnormalities, and some studies suggest reduced abundance in hotspots. The decomposition process itself is impaired in highly radioactive areas. Scientists have found that leaf litter breaks down more slowly in contaminated forests because the fungi and bacteria responsible for decomposition are inhibited by radiation. This has led to unusual forest floor conditions where decades of undecomposed plant material has accumulated. Plants show visible mutations in some areas, including unusual growth patterns and morphological abnormalities. However, forest ecosystems overall have recovered remarkably well, with young trees reclaiming former farmland and urban areas. The Chernobyl ecosystem status as a nature reserve is both inspiring and troubling. It demonstrates nature's resilience in the fact that human disturbance, including farming, hunting, logging, and development, can be more detrimental to wildlife than even severe radiation contamination. At the same time, the animals thriving in Chernobyl are not untouched by radiation. Studies have documented genetic damage, higher mutation rates, shortened lifespans, and various health problems across multiple species. The animals are surviving and reproducing, but they're doing so while carrying biological burdens that animals in clean environments don't face. The zone is a living laboratory providing invaluable data about radiation ecology, but a laboratory-born tragedy, and the animals within it are paying a price for their post-apocalyptic refuge. The Blue Dogs incident occurred at a time when Chernobyl tourism has become a significant phenomenon, drawing tens of thousands of visitors annually to witness what has been called the world's most famous disaster site. Organized tours of the exclusion zone began in the early 2000s and have grown steadily, with a dramatic surge following the success of the 2019 HBO miniseries Chernobyl, which brought renewed international attention to the disaster. Tourists pay for day trips or overnight stays in the zone, visiting the abandoned city of Pripyat, viewing the new safe confinement structure, and learning about the disaster and its aftermath. The Blue Dog story became part of this tourism narrative, illustrating both the ongoing interest in Chernobyl and the complex ways that the site functions as both memorial, research facility, and tourist attraction. Chernobyl tourism is carefully regulated by Ukrainian authorities. Visitors must book through licensed tour operators, follow strict safety protocols, and are accompanied by guides throughout their visit. Radiation exposure during typical tours is minimal. A full-day visit exposes tourists to roughly the same amount of radiation as a long-haul flight, but visitors are still monitored with dosimeters and must pass through radiation detectors when leaving the zone. The tours cover key sites, including the power plant complex, viewed from a distance, the abandoned town of Pripyat with its famous amusement park and decaying apartment blocks, the village of Zalishya, and various monuments to the disaster. Many tourists encounter the stray dogs during their visits, and feeding and photographing the animals has become a common part of the Chernobyl tourism experience. The emergence of the Blue Dog story in October 2025 created both opportunities and challenges for the tourism industry. On one hand, the viral story brought renewed international attention to Chernobyl at a time when tourism was still recovering from disruptions caused by the COVID-19 pandemic and the war in Ukraine. Tour operators reported increased inquiries from people fascinated by the Blue Dog's mystery who wanted to visit Chernobyl and potentially see the unusual animals themselves. On the other hand, the initial speculation about radiation-induced mutations and new contamination raised concerns among potential visitors about safety. Some tour operators found themselves fielding anxious questions about whether the Blue Dogs indicated dangerous new developments in the zone. Once the actual explanation, porta-potty chemicals, was revealed, the story became part of the mythology of the place, a modern addition to Chernobyl's collection of strange and surprising narratives. Tour guides began incorporating the Blue Dog's incident into their presentations, using it as an example of how misinformation spreads and how important it is to distinguish fact from speculation when discussing Chernobyl. The story also highlighted the ongoing presence of workers and infrastructure in the zone. The porta-potty in question was there serving the needs of the hundreds of people who work at the site daily, a reminder that Chernobyl is not simply a frozen time capsule, but a location where human activity continues. The broader phenomenon of dark tourism, visiting sites associated with death, disaster, or suffering, raises ethical questions that apply particularly to Chernobyl. Critics argue that tourism commodifies tragedy and shows disrespect to victims and survivors. Supporters counter that tourism serves educational purposes, preserves memory, and provides economic benefits to local communities. In Chernobyl's case, tourism revenue supports ongoing monitoring and maintenance activities, funds research, and provides employment for local residents who serve as guides, drivers, and support staff. Many survivors and former residents support tourism, viewing it as a way to ensure the disaster is not forgotten and its lessons continue to be learned. The interaction between tourists and the stray dogs adds another layer to this complexity. While feeding and photographing the dogs can seem like harmless fun, it encourages the animals to approach humans, which may not serve their long-term welfare, especially since only a fraction of zone workers are sympathetic to the animals. The Blue Dogs incident, in its own peculiar way, brought these ongoing debates about Chernobyl tourism into sharper focus, reminding visitors that the zone is not simply a museum but a real place with real animals, real workers, and real complexities. The rapid spread and eventual debunking of the Blue Dog story offers valuable lessons about how misinformation propagates in the digital age and how scientific truth struggles to compete with viral narratives. In an era when anyone can share information instantly to a global audience, the traditional gatekeeping functions of journalistic institutions and scientific peer review have been partially bypassed. This democratization of information has many benefits, but also creates challenges when it comes to maintaining accuracy and preventing the spread of false or misleading claims. The Blue Dogs episode demonstrates these dynamics in miniature. One key factor in the story spread was confirmation bias, the human tendency to accept information that confirms existing beliefs and to be skeptical of information that contradicts those beliefs. Many people already held beliefs about Chernobyl as a place of ongoing danger and mysterious mutations. The Blue Dog's images fit perfectly into this existing narrative framework, making them easy to accept without critical examination. When the actual explanation was revealed, some people initially resisted it precisely because it was too mundane. The porta-potty explanation didn't match the dramatic narrative they had constructed around the images. This psychological tendency affects how all of us process information and makes misinformation particularly sticky once it takes hold. The structure of social media platforms amplifies these problems. Algorithms prioritize content that generates engagement, clicks, shares, comments, and reactions. Sensational or alarming content typically generates more engagement than mundane explanations, so platforms' recommendation systems tend to promote the former over the latter. A post claiming radioactive mutant dogs will generally outperform a post explaining dogs rolled in spilled porta-potty chemicals in terms of platform metrics. This creates a systematic bias toward sensationalism, even when platforms don't explicitly intend this outcome. Content creators, whether they're major news organizations or individual users, face incentives to frame stories in the most attention-grabbing way possible, which often means emphasizing uncertainty, danger, or novelty over accuracy. The Blue Dog story also illustrates the bullshit asymmetry principle, sometimes called Brandolini's Law. The amount of energy needed to refute misinformation is an order of magnitude greater than the energy needed to produce it. Posting a dramatic photograph with a speculative caption takes seconds. Conducting the scientific investigation to determine what actually caused the blue coloration took days of fieldwork, laboratory analysis, and systematic investigation. By the time the accurate explanation was available, the false narrative had already spread to millions of people across multiple platforms and languages. Correcting those misimpressions will require reaching all those people again with the accurate information, a nearly impossible task. However, the story also demonstrates some positive aspects of the modern information ecosystem. Scientists and scientific organizations were able to use social media to communicate directly with the public about their investigation and findings. Dr. Brenner and the Clean Futures Fund shared updates throughout the process, providing transparency about how scientific investigation works. Science communicators and journalists with expertise in nuclear issues provided context and pushed back against the most extreme speculation. While these voices didn't always reach the same audience as the initial viral posts, they did provide accurate information for those seeking it. The episode highlights the ongoing need for scientific literacy education, critical thinking skills, and trustworthy sources of information that the public can turn to when evaluating viral claims. Moving forward, the Blue Dog story can serve as a teaching tool for educators, journalists, and science communicators. In a relatively low-stakes example, no one was harmed by temporarily believing Chernobyl dogs had been turned blue by radiation, but illustrates principles that apply to much more consequential forms of misinformation. Whether the topic is nuclear safety, public health, climate science, or any other area where scientific evidence matters for public policy and individual decision-making, the patterns seen in the Blue Dog story recur. Understanding these patterns and developing strategies to counter misinformation while promoting accurate scientific understanding remains one of the central challenges of the 21st century. The Blue Dogs incident, for all its viral fame and ultimate anticlimax, serves as a reminder that Chernobyl's story is far from over. Nearly 4 decades after the disaster, The site continues to pose significant challenges and raise important questions about nuclear safety, environmental management, and the long-term consequences of industrial accidents. The dogs may not have been radioactive mutants, but they exist in a landscape permanently altered by human activity, and their presence highlights the enduring complexity of the Chernobyl situation. The new safe confinement structure, completed in 2016 at a cost of approximately $1.7 billion, is designed to contain the remains of Reactor 4 for 100 years. However, this solution is explicitly temporary. Inside the sarcophagus lie approximately 200 tons of highly radioactive material, including nuclear fuel, contaminated structural materials, and the results of decades of decay and chemical reactions. Eventually, this material will need to be removed and properly stored, a process that will be extraordinarily dangerous, technically challenging, and expensive. No one has yet figured out exactly how this will be accomplished, meaning that future generations will inherit the responsibility for completing Chernobyl's cleanup. The exclusion zone itself will remain contaminated for thousands of years. While radiation levels have decreased significantly since 1986 due to decay of short-lived isotopes like iodine-131, long-lived isotopes including cesium-137, strontium-90, and plutonium-239 will persist in soil, water, and vegetation for decades, centuries, or even millennia. The area currently designated as the exclusion zone will require monitoring and restricted access far into the future. This raises profound questions about institutional continuity and knowledge preservation. How do we ensure that thousands of years from now, humans will still know that this landscape is contaminated and potentially dangerous? How do we maintain the institutions responsible for monitoring and managing the site across timescales that exceed the lifespan of nations and governments? The health impacts of Chernobyl continue to be debated and studied. While the immediate death toll was relatively low, fewer than 50 people died from acute radiation syndrome. The long-term health effects are more difficult to quantify. Thyroid cancer rates in exposed populations have been unequivocally linked to the disaster, with thousands of cases documented. Other health effects, including increased cancer rates of various types, cardiovascular disease, and mental health impacts, have been suggested by some studies, but remain controversial due to the methodological challenges of isolating Chernobyl's effects from other factors. The psychological and social impacts on evacuated communities have been profound and lasting, with entire ways of life destroyed and communities scattered. Chernobyl also continues to serve as a crucial case study for nuclear safety worldwide. The disaster revealed fundamental problems with Soviet-era reactor design, safety culture, and emergency response systems. The lessons learned from Chernobyl influenced reactor designs, operational procedures, and international safety standards. However, the world continues to operate hundreds of nuclear reactors, including many that are reaching the end of their design operational lifespans. The question of how to safely manage aging nuclear infrastructure while also addressing climate change, which has renewed interest in nuclear power as a low-carbon energy source, remained contentious and critical. The Blue Dogs and their accidental fame brought renewed attention to all these ongoing issues. For a few weeks in late 2025, Chernobyl was again at the center of international conversation, even if the immediate cause, chemical-stained dogs, turned out to be unrelated to radiation. This attention is valuable. Chernobyl's lessons need to be remembered and applied. Its challenges need to be addressed with sustained international cooperation and funding, and its victims and survivors deserve continued acknowledgement and support. The fact that a viral story about blue dogs can still draw global attention to Chernobyl nearly 40 years after the disaster is, in its own way, a testament to the enduring significance of the event and the ongoing need to grapple with its consequences. For all the tragedy and ongoing challenges associated with Chernobyl, there are also stories of hope, resilience, and unexpected positive developments. The Blue Dogs, once their true situation was understood, became an oddly uplifting symbol. Proof that life not only persists, but can thrive in ways that surprise us, even in the world's most infamous disaster zone. The broader story of Chernobyl's dogs demonstrates remarkable adaptability and survival against overwhelming odds, qualities that mirror the resilience shown by the human communities affected by the disaster and the scientists and workers who continue to manage its legacy. The work of organizations like the Clean Futures Fund represents one of the most heartening aspects of the modern Chernobyl story. These veterinary teams travel regularly into the exclusion zone, often in challenging weather conditions and logistically complex circumstances, to provide care for animals that most of the world has forgotten. Their efforts have spayed and neutered over 1,000 dogs, vaccinated hundreds more, and treated countless injuries and illnesses. This work serves practical purposes: controlling population size, preventing disease spread, and reducing suffering, but it also serves a deeper ethical purpose. It represents humanity's capacity for compassion and our willingness to take responsibility for the consequences of our actions, even when those consequences affect other species and persist across generations. The genetic research being conducted on Chernobyl dogs holds genuine promise for human medicine. Understanding how these animals' DNA repair mechanisms have adapted to chronic radiation exposure can inform cancer treatment strategies, radiation protection protocols for medical workers and astronauts, and our broader understanding of cellular resilience. The dogs didn't choose to become research subjects, but the knowledge gained from studying them may ultimately benefit millions of people. In this way, the descendants of abandoned pets have inadvertently contributed to scientific progress in ways their original owners could never have imagined when they were forced to leave them behind in 1986. The exclusion zone's transformation into an involuntary nature reserve, while arising from tragedy, has demonstrated important ecological principles. It has shown that wildlife can be remarkably resilient, that ecosystems can recover from severe disturbances, and that human disturbance is often a more significant factor limiting biodiversity than even severe contamination. These lessons have implications for conservation strategy worldwide. The fact that critically endangered species like Przewalski's horses are finding refuge in Chernobyl suggests creative possibilities for conservation in other contaminated or abandoned landscapes. While we certainly shouldn't contaminate areas to create wildlife refuges, the Chernobyl experience shows that land we've written off as irreparably damaged may still serve important ecological functions. The human communities affected by Chernobyl have also demonstrated remarkable resilience. Despite being displaced from their homes and facing ongoing health concerns and stigmatization, many evacuees have rebuilt their lives, formed new communities, and worked to preserve the memory and culture of the places they lost. Some elderly residents, known as self-settlers, even returned illegally to live in the exclusion zone, preferring to spend their final years in their ancestral homes despite the risks. Their determination to maintain connection with their land and way of life speaks to the deep human need for place and belonging, and their stories add another layer of complexity to Chernobyl's ongoing narrative. The scientific community working at Chernobyl has turned tragedy into opportunity for learning. Researchers from around the world conduct studies in the exclusion zone across disciplines, including radiation biology, ecology, nuclear engineering, sociology, and psychology. This international scientific cooperation has produced valuable knowledge, while also fostering connections between researchers from different countries and cultures. The exclusion zone serves as a unique outdoor laboratory where questions impossible to study elsewhere can be investigated, contributing to our understanding of radiation effects, ecosystem recovery, and long-term disaster management. The Blue Dog story, in its own peculiar way, contributes to this narrative of resilience and hope. The fact that the alarming images turn out to show nothing more than dogs rolling in porta-potty chemicals was, after initial disappointment, actually good news. It meant there was no new radiation leak, no emerging crisis, no evidence that Chernobyl's dangers were evolving in unpredictable ways. The dogs were fine, smelly and blue, but fine. They continue to live their lives in the exclusion zone, receiving care from workers and veterinary teams, adapting to their unusual environment, and reminding us that life is persistent, adaptable, and often surprising. As we reflect on the Blue Dog's mystery and the broader Chernobyl story, we're reminded that truth often turns out to be different from our initial assumptions, that viral narratives should be met with healthy skepticism, and that scientific investigation remains our best tool for understanding the world. We're also reminded that disasters, while devastating, don't write the final chapter. What follows, the recovery, the adaptation, the lessons learned, and the ongoing efforts to manage consequences, is just as important as the disaster itself. Chernobyl's legacy includes tragedy and ongoing challenges, but also includes scientific progress, ecological recovery, international cooperation, and countless individual acts of compassion and dedication. The dogs at Chernobyl, blue or otherwise, will continue to live in the shadow of Reactor 4, their genetics quietly recording the history of radiation exposure across generations, their daily lives intersected with workers who share food and affection, their presence serving as a living reminder of both what was lost and what persists. They didn't ask to become symbols or research subjects or viral sensations, but they've become all three, and in doing so, they've helped keep Chernobyl's story alive in public consciousness. And keeping that story alive, learning from it, remembering it, and applying its lessons may be the best hope we have for preventing future disasters and managing the legacy of past ones. If you found this deep dive into the mystery of Chernobyl's blue dogs fascinating, make sure you don't miss our upcoming videos exploring more untold stories from history's most intriguing disasters and mysteries. We're constantly uncovering the truth behind viral stories, separating fact from fiction, and revealing the real science behind phenomena that capture the world's attention. Hit that subscribe button and ring the notification bell, so you'll be the first to know when we release our next investigation. Have you heard other strange stories about Chernobyl or other disaster sites that you think might be myths or misunderstandings? Drop them in the comments below. Your suggestion might become our next video. Share this video with anyone who saw those viral blue dog images back in October 2025. They deserve to know the truth behind the mystery. And while you're here, check out our playlist on nuclear disasters and their environmental impacts. There's so much more to learn about how these events shape our world decades after they occur. Thanks for watching, and remember, always question what you see online. Seek out the scientific truth, and never underestimate the resilience of life, even in the most unlikely places. We'll see you in the next video.